Hello everyone, welcome to my YouTube channel. This is Megha K, currently pursuing my education in Sri Venkateshwara College of Engineering, Bengaluru. Third sem. The subject name is Digital System Design using Verilog. Subject code is VEC 302. The topic is about Verilog behavioral description. 8 is to 1 max, 8 is to 3 encoder and priority encoder. Verilog behavior description for 8 is to 1 max, 8 is to 3 encoder and priority encoder. Let's begin. Introduction to Verilog behavioral description. Verilog is a hardware description language used for modeling electronic systems. It allows designers to describe the behavior of digital circuits at a high abstraction level. This presentation focuses on behavioral description of an 8 is to 1 max and 8 is to 3 encoder and a priority encoder. First, we talk about what is an 8 is to 1 multiplexer. Here are some key points about 8 is to 1 multiplexer. An 8 is to 1 multiplexer is a combinational circuit that selects one of 8 inputs and forwards the selected input to a signal output line. Like if there are 8 inputs, there will be 1 outputs and the selection lines will be 3. The selection of the input is determined by 3 select lines. This device is widely used in digital circuits for routing data. Now let's talk about Verilog code for 8 is to 1 multiplexer. Here you can see the code. The Verilog code for an 8 is to 1 max can be written using a case statement. For clarity, the input and output ports are declared at the beginning of the module. The selected input is assigned to the output based on the value of the select lines. Behavioral description of 8 is to 1 max in Verilog. Here is an example of behavioral code for an 8 is to 1 max. Here you can see code. The code implements an 8 is to 1 mux using behavioral Verilog. A multiplexer selects one input from 8 indexed as in 0 to input 7 based on a 3-bit select line and forwards it to the output. Module declaration. Module mux 8 is to 1 input 7 is to 0 input. Input 2 is to 1 select line. Output is in 7 is to 0 an 8-bit input vector representing the 8 possible inputs to the mux. Select lines 2 is to 0 a 3-bit select signal used to choose one of the 8 inputs. Output. A single output declared as registered because it is assigned within an always block. Always block indicates a combinational logic block. The output is updated whenever any of the inputs or the select signal changes. Let's go for the case statement. This conditional block selects the output based on the value of the 3-bit select lines. 3-bit when it is select line is 0, 0, 0, the output will be 0. When the select lines is 0, 0, 1, the output will be 1. When the select lines is 0, 1, 0, the output will be 2. When the select lines is 0, 1, 1, the output will be 3. Like this, it continues. Conclusion: this code defines the behavior of an 8:1 multiplexer. The output depends on the 3-bit select lines, allowing the mux to route one of the 8 inputs to the output dynamically. Let's go for encoder. What is an 8:1 encoder? As you can see the diagram, an 8:3 encoder is a digital circuit that converts 8 input lines into 3 output lines. The output represents the binary value of the active input line. Encoders are essential in applications where multiple inputs need to be represented in an compact form. Verilog code for 8:1 encoder. The Verilog implementation of an 8:3 encoder typically utilizes a priority scheme. The highest priority input, that is active, determines the output code. Redundant inputs must be handled appropriately to avoid incorrect outputs. Behavioral description of 8:3 encoder in Verilog. Before going to the code, let's talk about the 8:3 encoder. Introduction to encoders. An encoder is a combinational circuit that converts two n input lines into an n-bit binary code. For an 8:3 encoder, 8 inputs are converted into 3-bit output. Second one is module declaration. This defines the Verilog module. Inputs and outputs are input 7:1, input 8-bit inputs. Output registered as 2:0, 3-bit output declared as a register because its value is updated in an always block. Always block the triggers whenever there is a change in the outputs. Inside this block, a case statement is used to handle multiple conditions. Case statement. The case is used for pattern matching. Here Z treats as wildcards. Each case represents a priority level. This ensures the highest priority bit is selected if multiple bits are high. Default case. Out of 3-bit handles the case where none of the inputs are active, ensuring the output is invalid. And the 6th is end of the block, end case and end close case statement and the module respectively. And the 7th one is purpose of the code. The code ensures the priority encoding where the highest priority input among in 7:0 determines the output. Let's go for the example. If input is 8-bit 00100000, only in 5 is high. The case 8-bit matches and the output is 3-bit 101. What is priority encoder? Let's go for the diagram. As you can see, there are 4 inputs and an enable and 2 outputs and an output for enable. A priority encoder is similar to a standard encoder but prioritizes which input to encode. It is designed to produce a binary representation of the highest active input. Priority encoders are crucial in handling multiple signals in digital systems. Verilog code for priority encoder. As you can see the diagram of priority encoder. The implementation of a priority encoder can also be done using behavioral model in Verilog. The code structure is similar to that of base encoder with emphasis on priority. The output logic is conditioned to ensure only the highest active input is recognized. Let's go for the conclusion. Verilog provides powerful constructs for modeling complex digital circuits behaviorally. The 8 is to 1 max, 8 is to 3 encoder and priority encoder are fundamental components in digital design. Understanding their behavioral descriptions in Verilog enhances the design and simulation of digital systems. Thank you.